Okay guys, just to clarify some problems, I'm going to run through these really quickly. If you need more of an explanation than what I give here, please let me know, and I can always slow down and talk more about it. Okay, so number one, I came up with the answer of C, and here's how it went down. So I added 5 to both sides, and then I divided by 2. Then, because this is an absolute value, that means that inside here I could have a positive 8 or I could have a negative 8. When I made it negative, though, I had to flip the sign, and then I just solved each of those. So if it was greater than 13, that means it went from 13 up to infinity, but it didn't include 13, so that's an open parenthesis. And then if it's less than -3, that means it went from negative infinity up to -3. Again, it didn't include it, so it was just a open parenthesis there. So that's where this answer came from. All right, number 2, they gave me a quadratic, and they wanted to know how many hot dogs must he sell to earn the most profit. So if you're wanting to find a maximum profit, if you're talking about a quadratic, this one is actually shaped like this. That tells me I need to find this right here, which is on your axis of symmetry, right? So I found the axis of symmetry using this, x equals negative b over 2a. That's the formula for that, which you just have to know. I'm not going to give it to you, so make sure you have that memorized. And then when I plug those in, so b was 60, I put a negative up front, and then 2 times a was -1 because it was negative x squared. And then I just simplified that and I got 30. That means 30 hot dogs is how many he would need to sell. Now, if they were asking me for like what was that profit, then I would need to plug that back into the function and find that y value right here to find out how much profit that was. But they didn't ask me for that. They just wanted this right here. All right, find all the solutions for the absolute value equation. So again, this one is really similar to this one, except it's an equation instead of an inequality. So that made it a little bit easier. I just didn't have to flip the sign when I got to this point, and then I just gave my 2 answers. And because it's an equation, you have 2 exact answers, not a interval like on this one. So you didn't have to use interval notation. You just said, these are my 2 answers. Okay, number 4, g of f means I'm going to take my f of x and I'm going to plug it into my g of x. Because they said g of f of x, that means I'm putting f of x into g. So that's what I did. I took this f of x right here and I plugged it in wherever I saw an x in g of x. So I plugged it in right there, so 3 times that minus 7. And then I simplified as much as I could, and that's how I got that answer. And then number 5, dividing this situation, what the easiest way to do it would be to multiply by the conjugate. So if I have 4 minus 2i on the bottom, I'm going to multiply by 4 plus 2i. And then when I do that on the bottom, I also have to do it to the top. So I like FOILed all of that out. And I got this, and then I started simplifying. When you simplify, what should happen is these 2 should always cancel out, which they did, and then these on the ends, you can simplify down to plus 4 and minus 10, and that saves you a lot of issue there. So then, once you get it down to a single number in the denominator, then you can separate it up into 2 terms with an I attached to that last one. So then that's that a plus bi form that they were asking for. Okay, number 6, write the quotient, same thing. So this is the exact same type of question. This time I did, I had 5 plus 2i on the bottom, so I multiplied by 5 minus 2i on the top and bottom. The exact same thing happened as that last problem. Number 7, find all the solutions for this equation. So the first thing you have to do, especially if it's a quadratic, is get it equal to 0. So I moved over that 6x and made it minus 6x. And then I used quadratic formula because this one was not factorable. If I thought about 11, factors of 11 are only 1 and 11, and that's not going to give me a 6 in the middle. So I used quadratic formula. If you don't remember it, you have to know it. Remember that. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So if you don't have this memorized, I would definitely do that for this test. Once I simplified it down, I got down to here and I had the square root of a negative number. And back in Algebra 1, we were like, okay, so that's the no real numbers is the answer. But there are imaginary solutions, so I need to write those out. So I factored out, I took this negative 8 and I factored it out into an I squared times a 4 times a 2. 4 times 2 is 8, and then I squared is that negative 1. So then I square rooted each of those. So the square root of I squared is I, that's where this came from. The square root of 4 is 2, that's where this came from. And then the square root of 2 is just the square root of 2. Then I divided each of these by 2. So I said this cancels that out, and this makes this a 3. So that gave me 3 plus or minus just an I square root of 2. Now, the way that they write it, remember it's supposed to be A plus BI. So I put the I on the end from here. That's the only thing I changed, just so that it was in that form. Okay. Number 8, find the difference quotient. This one is one, a lot of people struggled with this when we did it on the test. So let me give you a quick reminder here. When they're saying put f of x plus h, that means take x plus h and plug it in anywhere you see an x in this equation. So I put 5 and then x plus h squared plus 14 times x plus h minus 5. That's that first part. And then they're asking me to subtract f of x, which is exactly the function. Ooh, I didn't match up my letters. So this is f of x and this is a g of x. This is really that should be an f of x. All right, so f of x in this case minus that function and then all over h. So then you can simplify. So I multiplied out x plus h squared is really x plus h times x plus h. Well, that's x squared plus xh, so that's plus 2xh plus h squared, if I multiply all of that out. And then I was taking that times a 5. So that's where I got these 3 terms right here. Then I multiplied 14 times x and 14 times h, and then my minus 5 was just on the end. Then I distributed through this minus sign. So minus 5x squared minus 14x plus 5. What should happen at that point is lots of things should cancel out. Definitely these last 3 should. Just check your others and make sure there's not more. But so a 5 was right here, a 14x was here, and a 5x squared was here, and they all had opposite signs. So then that got me down to this statement. These are all I had left, divided by h, and you can divide all of those by h and get this. Now, a lot of times they have them in the wrong order, right? So I had mine as x and then h and then no variables. They had theirs as x, no variables, and then h. It's still the same answer. So just check those and make sure that you have all of those terms. Okay, number 9, find all the solutions for this equation. So when I saw this square root of x, I was like, yuck, I don't want to deal with that, so I'm going to square both sides. So I got x, and then over here, when I square that, don't forget to multiply it out. So don't just say that's x squared minus 4. That is not at all correct. It is x squared minus 2x plus 4. So that gives me this, minus 4x plus 4. Then I went ahead and subtracted this x, this extra x from each side. That gave me a minus 5x then, because it's like minusing 1x, minus 1x. That gives me a minus 5x. Then I factored, and then I set those equal to 0 and solved it. So x minus 4 equals 0 gives me x equals 4, and then this one gave me x equals 1. So there were my answers. Another option, let's say that you have no idea how to solve it. One really good option would be to go through and plug in your answer choices. That's always an option, so use it. This part B right here, or this answer choice B, that one would be very tough to plug in, but it is possible. I would start with your easier ones. So check this one, and if that doesn't work, check this one, and so on. All right, number 10. So this one, I started to write it out as a log, and then I was like, okay, I don't need to do that because 27 is really the same thing as 3 cubed. So then my bases are the same. If the bases are the same, you can just set the exponents equal to each other. And then solving that was super easy. This is another situation, though, where you could plug that in and see if it worked. Okay, number 11, solve the equation, give an exact solution. So they don't want you to give them a decimal if it comes out that way. They want it exact. So in that case, you would probably leave it as a fraction or like a specific log if it ended up that way. This one doesn't, though. So the first thing I did was, if they're adding right here and I have the same bases, that means I can multiply these two things. That's just a rule. And then once I do that, that gave me really just x minus 3 squared, because there's two of them. And then I was like, okay, well now I can rewrite this using my exponent rules. So this is really base 9 to the first power equals this part right here. And then I just solve. So this is those log rules that you just, again, you have to have that memorized. I'm not going to tell you that rule, so you just have to know it. So that gave me 9 equals, and then I multiplied that out. Luckily, whenever I subtracted my 9, that took that off, which means factoring it was really easy. I could just take an x out. I'm left with an x minus 6. Set those equal to 0. And then I want you to be really careful, because this one I got 0 and 6 as my two answers. But if I plug 0 in here, that means I have log base 9 of negative 3. And you can't do a log of a negative. So this one was an extraneous solution, which means 6 was my only answer. Okay, let me see if I can do a couple more, and then I'll do a second video for the rest. So number 12, solve the equation, round your answer to the to 3 decimal places. So this one I did have to put in a log form, because 13, I couldn't say that this is like 4 to some exponent, right? Or even 2 to some exponent. So if that didn't work, probably the easiest thing to do, and this is stuff that you did in Algebra 2, you could just take the log of both sides and then go from there. So this, bring it down front. So x minus 3 log 4 equals log of 13. Then I could divide by that log and get it as a decimal. So log of 13 divided by log of 4. Got that as a decimal, and then I added 3 to both sides. And that gave me about 4.85, which was answer choice B. All right, number 13. This one I feel like is going to be one of the more difficult ones for most people. Anytime we talk about domain and range, I feel like it's hard for you to think through. It's harder for you to visualize. So my suggestion to you is always make a table. If at all possible, make a table and sketch a graph so you can kind of see what's going on. If I give you a graph, you guys are pretty good at telling me what the domain is and the range. So I'm just going to have you graph. I think that's the easiest way to do it. So I plugged in some numbers and I got some answers. I just got these as decimals. I could have gotten them as fractions. Doesn't matter. So I kind of sketched what that would look like on the graph. And what I noticed was my domain, even though this looks like it kind of flattens out right here, if you look, it keeps going and going and going. So at 2, it would have been at negative 24. At 3, it would have been negative 124. So it's going to be really steep, but it's still going to keep going forever. There's no x value that would ever make it not work, okay? So that means my domain is going from negative infinity all the way to positive infinity. Any of those are okay. My range, I noticed that when I looked at my y values, that this kept getting closer and closer to 1. It was 0.8 and then 0.96 and then 0.992. And if I did negative 4, it was like 0.999 something, but it never got to 1. So that's something that you should kind of notice, that this 1 is kind of my cutoff point. So it could be anything below that. So from negative infinity up to 1 was my range value. So C was my answer on that one. Okay, 14, probably the toughest problem, in my opinion, that you really have to check everything. So they wanted to know, they wanted me to express the solution in interval notation, but this is a rational inequality. So I had to think about several things. First of all, if I was looking to just solve it, like if it just equaled 0 instead of greater than or equal to, I would get 2 and 3. So I factored that top part, and when the top part was 0, was at 2 and 3. So those values I knew were like pretty significant. And I just drew a number line. Really, this could be an XY axis. I just didn't make the Y axis because I don't really care what my Y values are. I'm just looking to see what's happening with my x values. Okay, so then I noticed that the denominator, if x was -3, or sorry, v, if v was -3, that would be bad in my situation because that would make that undefined. So at -3, I would have an open dot because it's undefined. So then I was like, okay, well, let's just check and see what's happening in each of these intervals. So anything less than -3, what's happening? Well, it came out to be negative. So I just plugged in -4. I was like, what's going to happen? Well, if I plug in -4 to this, I get a negative value. I forget what it was, but it was negative. Well, this is telling me it has to be greater than or equal to 0. Well, greater than or equal to 0 is positive. That's a positive value. So if it's negative, that does not fit that situation. From -3 up to 2, I was like, okay, what value could I plug in there? I just chose 0 because that's the easiest thing to plug in. So if I plug 0 in, I got a positive value. So if I plug 0 in here, 0 here, that gives me 6. 0 in here, that gives me 3. 6 divided by 3 is 2. So I got positive 2 there. That means that that is greater than or equal to 0. So that section works. That is a solution. This section right here, my only option was to plug in a fraction. So I plugged in 2.5. Again, I got a negative value when I did that, so that is not a solution. And then the last section, I picked 4 to plug in right here, and I got a positive value, which is greater than or equal to 0. So that was a solution. So that meant that my solution went from -3 up to 2, but it didn't include 3. It did include 2. So that's why my parenthesis and my bracket are the way that they are. And then from 3 up to infinity. So again, closed bracket on 3 and then up to infinity. Okay, so we'll stop there and I'll start with number 15 on the next video.